Today we want to have a look at application of complementary angles. So, in my previous video, I have already explained the meaning of complementary angles. If you haven't watched that, make sure you go and do so that you can have a better understanding of this part. And as a matter of fact, this is the last part of the topic, trigonometric ratio in a right-angled triangle. Now, let's have a look at the following questions. Let us solve these 5 questions to cover the whole of this topic on the application of complementary angles. Oh yeah, let's start. Number 1, sine theta rather is equal to cosine theta. Anytime you see sine of an angle equals to cosine of another angle, you remember complementary. It's as simple as that. So that means that you either change this cosine to sine or this sine to cosine. Whichever one you are changing, you will have to subtract the angle in front of it from 90 degrees. Please take note. So let me change this cosine to sine. That means sine remain sine theta. While cosine is to change to what? Sine. I will open a bracket. That means I will have to subtract this angle theta from 90. 90 degree minus what? Theta. So that is the logic. Once cosine has changed to sine here, you subtract this angle here from 90. If it was this one that changed to cosine, you subtract this angle here from 90. So sine will cancel what? Sine. That means we have theta equals to 90 minus what? Theta. So by the time you transfer minus theta here, it becomes positive. That means theta plus theta will be equal to what? 90 degrees. So theta plus theta is what? 2 theta. That will be equal to what? 90 degrees. Divide both sides by 2 to get your theta. What will now be theta? Theta will be 45 degrees. So that is the angle, the value of angle theta for question 1. Now this is second example question. Sin theta equals to cosine 50 degrees. If you like, you can change cosine to sine. But when you are changing cosine to sine, that means this will become 90 minus 50. You subtract 50 from 90. If you are changing sine to cosine, that means this theta will be subtracted from 90. It will now become 90 minus theta. But since 50 is a number, I would rather want to change this one. So that means sine theta will be equals to sine, open bracket, because it has become sine, it will now become 90 minus what? 50. So sine theta will be equals to, sine will cancel sine. So once sine cancels sine, what is now theta? Theta will be equals to 90 minus 50. So theta is what? 40 degrees. That's the answer to this question 2. Now, this is question 3. Now, for question 3, let me change sine to cosine. That means cosine, open bracket, now be 90 degrees minus this 2 theta, because we have 2 theta in front of sine here. It is whatever you see in front of the trig, you subtract from 90. Anything you see there is equal to cosine 3 theta. So, cosine will cancel what? Cosine. 90 degree minus 2 theta is equal to 3 theta. Then let us transfer this minus 2 theta here, become plus. That means 90 degree is equal to 3 theta plus 2 theta. And what will that give us? That means 90 degree equals to 5 what? Theta. Because 3 theta plus 2 theta is 5 theta. We now divide both sides by what? 5. When we divide both sides by 5, that means, let me write it here, 90 degree over 5 is equal to 5 theta over 5. So what will be theta now? Theta will be equal to 5 in 90. That is 18 degrees. So that's the value of theta here. 18 degrees. Now, we want to solve question 4. Since there is a bracket here already, and this one has no bracket, it will be safer and faster to deal with the one with only a single symbol. That means I will change this one to sine. I will leave this one as it is. Sine into bracket alpha plus 20 is equal to sine into bracket 90 minus alpha. So I will subtract this alpha from 90. Sine will cancel sine. Alpha plus 20 is equal to 90 minus alpha. Let's collect the right terms of alpha and the numbers. Minus alpha will come here, become plus. Plus 20 will come here, becomes minus. So alpha plus alpha will be equals to 90 minus 20. Alpha plus alpha is 2 alpha is equal to 70. So divide both sides by 2. Alpha will be what? 35 degrees. So let's have a look at the last example, which is question 5 that I've copied here. Now this time around, we are left with no choice. Both sides have bracket. So you can decide to change anyone. So let me change the left side, which is sine, to cosine. That means cosine, open bracket. I will now subtract the whole of alpha plus 5 from 90 degrees. That will now be 90 degrees minus this bracket now, which is alpha plus 5. So the whole of the bracket is what I'm subtracting from 90, as you can see, equals to cosine, open bracket, 2 alpha minus 20. This one remains as it is. So finally, cosine will cancel cosine. And I have 90 minus open bracket alpha plus 5 equals to 2 alpha minus 20. So let me open this bracket with this negative sign. That will be 90 minus times alpha minus alpha minus times plus 5 minus 5 equals to 2 alpha minus 20. Let's collect the right terms of alpha. Minus alpha, when it crosses to this side, it becomes positive. And when minus 20 comes to this side, it becomes positive. That means this will now be 90 minus 5, because minus 5 is here already. Then minus 20 coming here will become plus 20. Then equals to the 2 alpha we have here. Then minus alpha coming here will become plus alpha. As simple as that. So that means 90 minus 5, that's 85. 85 plus 20, that's 105, equals to 2 alpha plus alpha, 3 alpha. Divide both sides by 3. So what is now alpha? 3 in 105, that will be 35 degrees. So alpha is 35 degrees. So I'm going to write some questions on the board for you to practice. You can forward your answers to my WhatsApp once you are done with them. These are the practice questions.